Ask my instructor 11.3.25. Find the area inside one leaf of the rose. The general shape of this polar curve is a flower with petals coming out from the pole. What we want to do is plot enough points that we can see what's going on in order to find the area of one petal. In choosing angles, I like to think in terms of the unit circle. For example, I know sine and cosine for pi over 6. And the angle theta is multiplied by 5. So 1/5 of pi over 6 would be my first choice after 0. I also know that cosine is 0 for pi over 2, so 1/5 of pi over 2 would be my last choice for theta in this sequence. And this is only a starting point. If we need to come back and plot some more points, we will. So evaluating 2 cosine 5 theta, this is what I get. And then for some of the values, I need to get an approximation for it so I can plot. All right, so we're ready to plot now. The radius is 2 when theta equals 0. That is the greatest value that r can have for this polar equation. Now, why is that? Cosine goes between -1 and 1. So twice of cosine goes between -2 and 2. So if I'm at a place where r equals 2, I'm at the greatest value for r. So if r equals 2, that has to be the top of a petal. And that's fantastic because we know that our starting point is the top of a petal, and that gives us a reference. So we're at the top of a petal, and of course that means that as theta increases, the radius will be decreasing, and by our choice of theta, when we get down to theta equals pi over 2, we're down to a radius of 0, which means we have 1/2 of a petal here, going from theta equals 0 to theta equals pi over 10. That worked out very nicely, didn't it? So 1/2 of one petal is traced out from theta equals 0 to theta equals pi over 10. What we're going to do is find the area of the rose from theta equals 0 to theta equals pi over 10, and then multiply our answer by 2, and that will give us the area of one complete petal. The equation of the rose is r equals 2 cosine 5 theta, so the square of the function r equals f of theta would be r squared equals 4 cosine squared. And the area of 1/2 of one petal is this integral. What we need to do is we need to simplify the integral, and I'm going to use the double angle formula, also known as the power reducing formula. After I use the double angle formula, I go 2 times 1/2, and this simplifies very nicely. So this is not very difficult for us to integrate at this point, and we are now ready to integrate. So go ahead and integrate. After we integrate, we evaluate. So I'm evaluating from theta equals pi over 10 as my top bound, and theta equals 0 as my bottom bound. Now I need to find out what sine of pi is and sine of 0 is, and I'm recalling that they're both equal to 0. And so my final answer will be pi over 10. So the area of half of a rose petal, the area from 0 to pi over 10 is pi over 10, so the area of one complete petal is pi over 5. Take care and have a great day.